In the last video, we had just mentioned that pyruvate carboxylase is a mitochondrial enzyme, but the next step of the processes of gluconeogenesis is the phosphoenol pyruvate carboxykinase. And this is going to convert oxaloacetate, if I could find the blue, with the use of GTP to phosphoenol pyruvate. So I didn't really have room to list GTP as well, but those are the two things that it's going to be reacting with to convert it into phosphoenol pyruvate and CO2. And it's not really that important, but also GDP. Okay, so one of the things that I wanted to mention about oxaloacetate, because phosphoenol pyruvate carboxykinase, and I'll just go ahead and mention it here, that this is a cytoplasmic enzyme, whereas pyruvate carboxylase was mitochondrial. So it's in the cytoplasm. So how do we get oxaloacetate out of the mitochondria, right? So it's going to be exported from the mitochondria as malate. Then it's going to react with an NAD plus and a couple of other enzymes. I'm not really going to stress that so much as the fact that it's going to be through the use of a redox reaction, giving us NADH and then oxaloacetate. And while you probably can't tell just from the name malate to oxaloacetate, notice that NAD plus went from NADH. NAD plus has been reduced, so obviously malate has been oxidized to oxaloacetate. The only thing that I think is important is that you understand that it's a redox reaction. So what this phosphoenol pyruvate carboxykinase does that I think is pretty interesting is that it's going to simultaneously decarboxylate and phosphorylate. To go from oxaloacetate, the decarboxylation obviously gets us back to pyruvate, and then the phosphorylation gets us back to phosphoenol pyruvate. So why are we doing this? Why are we carboxylating it and then decarboxylating it along with phosphorylating it in the process? And the reason is that the addition of just a phosphoryl group to it is very unfavorable, right? We're trying to fight against pyruvate kinase. And so in gluconeogenesis, the way that we can carboxylate it and then follow by decarboxylating it reduces the, I guess, overall positive nature of our delta G. And so what we're doing essentially, we're just coupling these two reactions, an unfavorable one with a favorable one, to get a more closer, it's still positive, but it's kind of closer to negative delta G value. And what you'll find out is that decarboxylations and then carboxylating something is a very common way that we can have reactions driving in the directionality that we want, right? So this is not just used I'm just going to equals love, or we're happy. This is not something that we're just going to be using for the purposes of gluconeogenesis. You'll see this come up in other types of metabolism courses.